Hello, today we'll discuss about gaseous state formulae. All gaseous state formulae we'll write at one place, which are useful for your entrance examinations. So the lesson starts with the measurable properties of gases. Measurable properties. So in this measurable properties, the first one is mass. The mass units are number of moles. Number of moles is equals to mass by molecular mass. Both you can take in grams. Number of moles we can use, or we can use gram, or we can use kilogram, where kilogram is called SI unit. So mass, number of moles is equal to mass by molecular mass, or mass in gram by gram molecular mass. Some other units are gram or kilogram. Then volume. Volume units are liters. 1 liter is equals to 1000 ml, are equal to 1000 cc, are equal to 1 decimeter cube or cubic decimeter. Fine. 1 liter is equals to 1000 ml, 1000 cc, 1 decimeter cube. And volume is generally measured by using gas burette. This is the apparatus. Then coming to pressure, pressure is measured using barometer and manometer. Pressure is equals to force per unit area. This is your physics formula. P is equals to F by A. Here we discuss the units in atmospheres. 1 atmosphere is equals to 760 millimeter of mercury, or 1 atmosphere is equal to 76 centimeter of mercury. 1 atmosphere is equals to some other units I am taking, 760 tar. That means 1 millimeter is equal to 1 tar. This is the conversion factor. You can say 1 millimeter is equals to 1 tar. Or 1 atmosphere is equal to 1,01,325 pascals. Or you can say 1.01325 10 power 5 pascals. Or 1 atma is equal to, you can say even in terms of 101.325 kilopascals. All these are different units. Or 1 atma is equal to 1.01325 bar. So 1 atma is equal to 1.01325 bars. That means bar is little lesser value than atmospheres. All these are the units for pressure. Then temperature. Temperature is generally given in kelvins or degree Celsius. Kelvins is equals to whatever the degree Celsius is there, that should be added by 273.15. We take 273, fine. 273.15 we take. So temperature. So these are the 4 measurable properties: mass, volume, pressure, and temperature. The relations between them, among them, is called gas laws. So gas laws will take. Gas laws are the relations among mass, pressure, volume, and temperature. If you are saying the relation between these two, these must be constant. If you are saying the relation between these two, these must be constants. If you want to say the relation between M and T, PV must be constants. Okay. Then what is the first law? First law is Boyle's law. Boyle's law, V is proportional to 1 by P. At constant, these words are important: temperature and mass. Or PV is equal to constant, or P1 V1 is equals to P2 V2. This is a fast capture. Okay, This is useful for your all entrance examination. Or log P plus log V is equal to constant. PV, na? So when you are writing log, that should be plus. Log P plus log V is equal to constant. The graph line will be like this. This is T2 temperature, this is T1 temperature. Here pressure, if you take T2 greater than T1. These graph lines are called isotherms. Isotherms means they are drawn at constant temperature and their shape is rectangular hyperbola. Mathematics students can easily say what is rectangular hyperbola. For science students, you just see like this shape is called rectangular hyperbola. Then coming to Chas's law, V is proportional to T. This is Chas's law at constant pressure and mass. The volume of a given mass of gas is directly proportional to absolute temperature. V1 by T1 is equals to V2 by T2, or V by T is equal to constant. Then log V minus log T is equal to constant. All that we can take. The graph is little interesting. If you take a line here, the remaining line we show with dotted line. If this is at 0 degree Celsius, this is taken at 0 kelvins. At 0 degree Celsius, this we are taking volume and temperature relation. This graph line is drawn at constant pressure. It is constant pressure. It is called isobar. Here it is not, the volume is not equal to 0, but at this point it is reaching to 0. Not even at 0 Kelvin. Before reaching 0 Kelvin only, all the gases will become 0. At 0 Kelvin, there is no gas. All the gases will be in the liquid form. So these graph lines are called isobars. And if they want to ask, they can ask you one more line. This is V versus T. This is P1 graph and this is P2 graph. P1, P2, what is the relation between P1 and P2? This question can be asked. You can use some concept here. Here volume is more for P2, so P2 is less. Simple, na? Here volume is more, that means pressure is less, so P2 will be lesser and P1 is more. So this type of questions are important. Then pressure temperature law. It is again same. P is directly proportional to T at constant remaining 2, that is volume and mass both must be constants. So P by T is equal to constant, or P1 by T1 is equals to P2 by T2. This is another very important. Generally based on this, the questions will be asked like, a cylinder is with some 15 atmosphere pressure, the temperature is 273. If the cylinder can hold up to 18 atmosphere pressure, what may be the temperature at which the cylinder will go for explode? Then P1 by T1 is equals to P2 by T2 formula you can use. Then coming to one important law, that is Dalton's law. Dalton's law is pressure total is equal to P1 plus P2 at given conditions. That is volume and temperature must be constant. Temperature, volume must be constants for Dalton's law. So in this case, if you want individual gases pressure, then total pressure into its mole fraction. Total pressure into mole fraction will give you individual pressure of the gas. This is about Dalton's law. Conditions is the reacting gases should not be taken. NH3HCl you should not take. SO2 plus SCl2 you should not take. Such kind of are not accepted because they react with each other. So the statement will be like this: a non-reacting gaseous mixture. So we should not use such. Then Gram's law. Gram's law is about rate of diffusion, or is proportional to 1 by root d or 1 by root m. R is rate of diffusion, D is density, M is molecular mass. So the expression will be R1 by R2 is equal to under root of D2 by D1 are under root of m2 by m1. R1 by RT is equals to under root of d2 by d1 or under root of m2 by m1, or R1 by R2 is equal to under root of vapor density Vd2 by Vd1, or R1 by R2 is equal to R equal to V by T, where V is volume, T is time. So V1 T2 by V2 T1, right? R1 by RT is equal to V1 V2 by V1 T2 by V2 T1. This is the formula because rate of diffusion is equal to volume diffused by time. This is all for Dalton Graham's law. Graham's law is there that is when you are saying R is proportional to 1 by root D, this is at constant pressure and temperature. If the pressure is not constant, the formula will be R1 by R2 is equal to P1 by P2 into under root of D2 by D1. So we have to keep here P1 by P2, R1 by RT is equals to P1 by P2 under root of D2 by D1. This is the point that you have to remember. Then Avogadro's law. What is Avogadro's law? V is proportional to N at constant Pt. Pt both are constants. So V is proportional to N. This you can say in some other terms, all equal volumes of gases will be containing equal number of molecules. Avogadro's law, V proportional to N at constant pressure and temperature. 1 mole of any gas, 1 mole of any gas under STP conditions will be containing 6.023 into 10 to the power of 23 molecules. 1 mole of any gas under STP conditions 6.023 10 to the power 23 molecules, and the same will be having 22.4 liters of volume. So 22.4 liters of volume under STP conditions, any gas will be containing 6.023 10 to the power 23 molecules. So this is the, you can say, Avogadro's law. So Boyle's, Chas, Avogadro's, Dalton's, Graham's. Okay. Pressure, temperature. After all this, we have ideal gas equation. Ideal gas equation is PV is equal to nRT, where P is pressure, V is volume, N is number of moles, and T is temperature, R is universal gas constant. We are saying about all gases. R is equal to PV by NT. If you substitute pressure as 1 atmosphere, volume as 22.4 liters, number of moles 1, and temperature as 273 kelvins, then the value will come R is equal to 0.0821 liter atmosphere per mole per Kelvin. Liter atma per mole per Kelvin for R value 0.0821. Another value of R is 8.314 joule per mole per Kelvin. This you use for generally kinetic energy problems. You use this formula, this value. R is equal to 1.987 calories per mole per Kelvin. This is also same thing you use in case of kinetic energy formula. R is equal to 8.314 into 10 to the power 7 erg per mole per Kelvin. This you use for RMS velocity problems. RMS velocity problems, when R value is asked 8.314 10 to the power of 7 you use, then the RMS velocity will be in centimeters per second. Okay, so this is about R values. PV is equals to nRT. So this is the first part of states of matter. We will discuss next part 2 in coming session. Okay.